And hello, everybody. Good afternoon. Let's hope we can give you something interesting to learn about today and see how your careers could be in engineering. So I'm Kieron Salter. I am the owner and founder of a company called KWSP Special Projects, which has been doing motorsport and engineering related activities now for since 2002, so over 18 years. Before that, I was a race car designer, and I'll tell you a bit more about that as well. But I'm going to tell you a bit more specifically about the Digital Manufacturing Centre today, because that has a very real relevance to CAD, CAM, and actually what we more broadly call CAE, which is computer-aided engineering. So how do we apply that in additive manufacturing? So on my first slide here, I think this information was shared beforehand, so hopefully you've had an opportunity to do a bit of research into KWSP Special Projects and the Digital Manufacturing Centre, and maybe you've done some prep work around the technology and understanding some of the benefits and the applications, and perhaps you've already seen some really cool things that have been manufactured using additive manufacturing. So the Digital Manufacturing Centre at Silverstone is a really good example of where you could work if you were an engineer or somebody with specific skills in CAD, CAM or CAE. And it's worth pointing out, you don't have to be a fully qualified engineer to be in those positions. There are a whole range of opportunities in the engineering sector, depending on what your skill sets are, what your interests are, whether you're more academically focused or more practically focused. The Digital Manufacturing Centre at Silverstone is going to be about 20,000 square feet. It's mostly around manufacturing using additive processes. Now, those are processes that are very often called 3D printing. We probably all know or think we know what 3D printing is. Additive manufacturing is let's say, a more grown-up description of it. It's the professional description of that same process, which is building things normally layer by layer. In the centre at the DMC, we're going to have quite a lot of engineers, and we're also going to have apprenticeships and work placement schemes, and lots of ways in which young people can engage with engineering firsthand and see where your careers might be. So on the screen there, you obviously see the centre, but you can see a much younger pre-lockdown version of me, and Nigel, the COO, who is somebody else that you might actually engage with if you were to become involved with the COO because of the DMC, because he's going to run that facility on a day-to-day basis. In the top right-hand side, because we haven't finished building it all yet, there's a virtual image. Again, one of the things that we can do when you're using a digital asset, which we've created in CAD. So we're able to create a virtual rendering of the building long before we even enter it and occupy it, which means that we can do layouts, walkthroughs, and other understandings. Let me suggest, well, let me explain really what I was saying at the beginning about CAE, because CAD and CAM is a very important tool, but CAE is the more broader term for everything around simulation. And in order to do simulation, you need to have CAD, and probably the CAM comes directly from that. So CAD and CAM kind of were the only digital formats of that we had previously. Now we can do finite element analysis, we can do CFD, which is computer virtual wind tunnel testing, and we can also do essentially automatic design processes based on computer simulation. I always say that being an expert in CAD or CAE doesn't make you an engineer, in the same way that being able to use a word processor doesn't make you an author or a writer. You still need to learn the core skills that are needed for engineering, and CAD is just one of the ways in which you'll express that and use it to make things. So in order to make something, in particular at our Digital Manufacturing Centre, you'll need to do some CAD to create the geometries and the manufacturing files that are then used. So let me give you an example of an engineering pathway. Mine is hopefully an interesting one. I've certainly enjoyed the route that I've been on. But when I was at school, design and technology were really important to me, very interesting subjects. I liked it quite often because there was a lot of practical element to it. But I like the concept of manufacturing things and being innovative and creating solutions to problems. When I finished at school, And it's important to say also at this point, I wasn't the best academically at school, and I found school quite hard work. But I naturally focused on the sciences and technology. But then I went on and did my A levels this was my route. And I chose those A levels specifically so that they would give me access to university to go and do a degree in mechanical engineering. Now, it turns out I wasn't very good at A levels, and I dramatically failed them. I got 2 E's and a U, and I realized that I wasn't going to be able to get into university to do the degree course that I wanted to do. And I was given the option of doing an HND, which is similar in terms of academic level to A levels, but was more focused on the subject that I enjoyed, which is engineering. So it was a much more contextual learning process. So I did the HND instead of doing the degree, and I found that much easier because it was about a subject I understood. I was learning the same things in terms of maths that I needed to have as a skill to solve problems, but I now understood why I was doing it and what I was doing it for. And hopefully lessons like this will also help understand where the opportunities might be and why you're learning certain things that you're learning outside of subjects of DIT even. So I did my HND, and actually that fortunately gave me an opportunity to go in and do a degree course from that. So I chose to do a degree, which was an extra 2 years. And that gave me a more academic understanding on top of my HND platform. And there was another benefit of that, as it turns out, in that on the day that I graduated from my degree course, I bumped into a guy called Adrian Reynard, who was there on the day giving out the certificates and was guest of honor. Now, he owned a company called Reynard Motorsport, and he'd given a talk about his company, and I thought that sounds like a really cool place to work. So I took the opportunity there and then to ask him for a job, and that set me on my career path of working in motorsport, because I worked for Reynard Motorsport then for 10 years before I went on to set my own company up, designing cars for Le Mans. There's a picture there on the screen of one of my Le Mans cars from 2004. It was an innovative car because it actually ran, it was the first car and still the only car actually to have run at Le Mans on a sustainable fuel. So it was bioethanol. It didn't run on gasoline or diesel.
Kieron?
Yes.
And just tell us, for those of us that don't know about Le Mans, what is that? It's quite a famous race, isn't it?
Le Mans is probably, yeah, there are several famous races in the world. There's the Monaco F1 Grand Prix, the Silverstone Grand Prix. There's the Indy 500 in America, and then there's the Le Mans 24 Hours in France. And it's one race a year, and it is a 24-hour endurance race where the cars compete against each other, doing pit stops and driver changes, and crew have to sleep, or they don't sleep very often. So there's a whole endurance element around it. But it's a very famous race, been going for a very long time, almost since the birth of the automobile. And it's actually one of my favorite types of racing, endurance racing. We're involved in Formula One and IndyCar too, but I have to say that endurance racing is quite special.
Does it put quite a lot of pressure on the engineering team, 24 hours of racing?
Yeah, so in my role, after we designed the car, my role at the circuit would normally be sitting on the pit wall, tracking the car throughout the whole event, monitoring its fuel levels and tyre usage, and making strategy calls. And in that role, you don't go to sleep. The drivers get the benefit of having a rest after they've done their 30-minute stint. No, the engineers and most of the crew in the garages get an opportunity to rest between pit stops. But it's more than 24 hours awake as well, because the race is 24 hours. But of course, you've got build up before that, and then you've got to get back to the hotels afterwards. So it's more like a 36-hour race by the time you've finished. So quite exhausting.
Sounds intense, but thank you very much for explaining.
But this is probably an important message. The reason I chose motorsport to be an engineer is because it gave me what I felt was going to be the best opportunity to enjoy my work. It is a challenging and high profile environment, but at the end of the day, it is still a job. So you still have those issues with having to go to work in the morning and stuff, and not always wanting to. But my single piece of advice to anybody is, first of all, identify what you're passionate about, and then try and find or forge a career in that sector, in that area, because you'll always then be happy with the work that you're doing. So Having set up my own motorsport company in 2002, several more companies have come from that. So there's the Digital Manufacturing Centre. There is KW Special Projects, which focuses on automation and machine design. And it's given us, not just me, but the people that work for me, some pretty cool opportunities, like getting involved with Jimmy DeVille there on Quest TV, Fifth Gear, where they came to film us doing some reverse engineering and manufacturing for some cars. You know, and lots of other cool stuff. And I'm going to show you some cool things in a minute, I hope, that inspire you and make you realize that engineering is really, you know, touches everything that you get involved with, whether it's software, whether it's a bridge that you drive over, or a train that you get in, or an aeroplane, or even the sport that you watch on TV. One of the things that's not in this presentation that we got involved with a couple of years ago is we actually designed the sled for the British skeleton team that won at the Olympics in the Winter Olympics in 2018. You know, and so my team can say that they actually won a gold medal and 2 bronze medals at the Olympics. So there's lots of cool stuff that you can do if you have some of the skills that you need to work in the engineering environment. So let me move on to what the DMC does. Remind me if I'm running out of time, Chris. This is a speeded up version of 3D printing. You know, it's 3D printing, or additive manufacturing, as we call it, is really building things layer by layer. So we take a 3D object and we can slice it into 2D objects. So if you imagine everything being built out of 2D slices, each slice that you makes a different profile, and the machine technology that you use just creates those profiles on top of each other, and eventually you build up a part. The reason that we find that useful is it means you don't have any tooling. It means you only use the material that you need. So you're not machining material away, you're adding material only. And it means you can make some geometries and parts that you couldn't make in other ways because of the uniqueness of the process. And that's a plastic machine. So a lot of us are familiar with the machines that you can even buy for home for less than £100 that 3D print parts in plastic. But there's other processes as well that use lasers. And those lasers will either cure a liquid, or those lasers might melt a powder. So the video on the left, which is just come up, hopefully it's showing, you'll see some sparks flying. That's because what you can't see is there's a bed of titanium powder, and then there is a laser above those that is controlled by the CAD files, by the CAD CAM, and that laser is then melting little puddles of titanium from the powder and essentially welding it together and building parts layer by layer from powder. Now all of these technologies we have at Silverstone, and the metals are perhaps the most interesting from an industrial application, because we can start to think about using those parts for real applications in space, aerospace, automotive, motorsport. But plastics have a lot of opportunities. In the past, a lot of this technology was called rapid prototyping, and it was really only ever used for that, just to speed up manufacturing, to make test parts or trial parts that really weren't functional or useful. Now the technologies are starting to mature. We're actually able to make production parts and production runs of parts, and not just in metals and polymers, but also other materials like ceramics. And we're also developing processes even for printing batteries. So additive and digital manufacturing is really, really key to the future of manufacturing in the UK and the world, but it's all driven by good engineering and CAD and computer-aided engineering at the start. If you don't have a digital model of what you're trying to make, you can't make it using these technologies. So here's an example. You've got what you might normally only be able to design by drawing on a drawing board, or even just making it as you go along, part on the left-hand side at the start of our part, which is functional, it works, but it's not optimized. Then we start doing some design for additive manufacturing and using CAE tools like topological design and finite element analysis that are really ways in which the computer, using machine learning and built-in formulas, optimizes and speeds up the process that you might do by hand calculations. And we're able to optimize that solid lump of 30 kilo functional part on the left to a part that's much, much lighter. But now it's very difficult to manufacture. And if I had drawn something like that when I first started my career in engineering, I'd be told to start again because it can't be made for the right price. And I'd end up with something that's on the, like we started with, a big lump that was easy to machine just on a 3-axis CNC machine. So now we can design a part that's very complicated. We need to find a process to make it, and that's where additive manufacturing plays in. So we can now manufacture parts like that very cost effectively and very quickly. But then you'll still see it's quite edgy and easy to draw, in want of a better description, easy to conceptualize and design. And if you start using techniques like topological design, you can actually teach the computer the rules that you want it to use to design the part. So you can put in the important features, you can put in the load paths and where it might break, and you can put in material properties. And actually the computer will go through several optimizations and will create you a part that is much more optimized for its application and reduces the weight and can be manufactured using additive manufacturing. And it's probably no surprise when you start looking at these sort of parts that they actually look quite organic and quite like nature. And that's because that's exactly what a tree does. That's exactly what a bone does when it grows in your body. Is it's optimized and it only uses the material it needs, and it has understands its own load paths, and it sort of corrects itself. So when a tree grows, if the branches become too heavy, it actually grows more material around the branch to make it stronger. And it's the same with your bones in your body. If you break a bone, you get growth to heal it and also to make it stronger. And that's what the computers can do now. We're teaching computers to come up with some of those intelligent formulas to help us design parts. Important to say also you still need to be an engineer, and it needs a human in the loop to say what you want and to understand where the important points of consideration are. So engineering, I said it's cool. There's lots of cool things you can do. I was very lucky. I got involved in motorsport early on, and there's no reason why any of you can't get involved in motorsport or areas of industry or technology that interest you. And I say this to lots of people. You know, if you're interested in music, but you're good at engineering, there's still a job for you in a recording studio or in a manufacturing division making equipment for Apple or wherever it is. You know, look at what you want to do and look at what you're interested in and what will get you out of bed in the morning to go to work. So you could be into aviation and you can go and work as an engineer or a technician in designing, building aircraft, or it could be automotive, in which case, of course, we're surrounded in this area by race car companies and high value automotive companies. It could be construction, and there's lots of engineering in construction and lots of needs for new technology, and they're starting to use 3D printing technologies now to build houses. You could be into space or medical or ordinary land transport such as rail. There's lots and lots of opportunities, and there's lots of things and lots of problems that still need to be solved. I think the only thing that is still the same since I started working in engineering is that wheels are still round, but the wheels design still keep changing. So there's lots and lots of stuff. This video hopefully will play. This is a really good example of something that couldn't be manufactured before. This is a 3D printed part in copper with lots of internal geometries that are difficult to manufacture normally, and it's part of a rocket engine. And you know, if you're the engineer that's involved in designing this particular part, you're also going to get involved in testing it and proving it works and validating it, and then going through the design loop again probably and reiterating that. And then this would be a part that would end up going to space on probably a satellite launch mission.
And Kieron, while we're watching these images, I'm going to ask you what your greatest achievement is, just because you've got such a varied and amazing career. It'd be really good to ask you that after this video, well, in question time. And we've got about 5 minutes left, so we're going well.
Okay, 5 minutes left.
Yep.
I will move on to the next video, the next picture, if we can. We'll go to the end. I didn't hear your question there.
Oh, sorry. It's probably because we couldn't hear the sound actually on that.
Ah.
Yeah.
Right.
I was filling, to be honest.
So let me give you an example of somebody I know, because it's probably boring just to hear about my career path. But this young chap, Sam, he went through an engineering training as just in the same way as I did, but he's very interested in rockets and space, and he was very interested in additive manufacturing, and he could see lots and lots of opportunities where you could design and build things specifically around additive that you couldn't have done beforehand. You know, he was using these new technologies that were very, very innovative and solving problems. And he's probably got the dream job, I think. You know, he is the real Iron Man. So again, you probably won't be able to hear the sound on this, but Sam is the designer of this jetpack suit. All the parts on this suit are 3D printed. Can you hear the sound, Chris?
No, we can't, unfortunately.
So all of these parts, as long as you can hear me, all of these parts are 3D printed. And quite a few of them are plastic, actually, even though there's lots of temperature. And we're still optimizing this, and he's going to be manufacturing these parts at Silverstone, at our new facility. So he's the designer, the engineer, and also the test pilot. I'll move on to the end so that we don't waste too much time on that. Oh, come on. So I thought it'd be important to give you some things to think about as well, going forwards, and you know, what could you do to learn a bit more about what we're doing, and how can you engage with us? You're more than welcome to get in touch with us for any interesting questions around additive manufacturing, and certainly when you want to do work experience, or whether you want to do some summer placement works, you know, we offer those sort of opportunities, and I think there's lots of people in our area that do, and I would encourage all of you to get as much experience, work experience, as you can. Very, very important for an employer to understand that our potential employees are motivated and that they want to work in our area, in our sector. So work experience is important. You know, if you haven't done so already, go and find out a bit more about additive manufacturing, understand what the opportunities for additive manufacturing are, why they're beneficial. And because it's a very new technology, there are actually quite a lot of people that are changing the world in manufacturing in this area, because it's still growing and still changing quite quickly. So I think for me, I'm happy to close my bit at this point and open up to any questions there might be. But
great. Thank you, Kieron. Really insightful presentation. A question from Aylesbury Vale Academy. What is the salary that engineers get? Oh,
well, that very much depends. Very much depends. And I'd say that, you know, it does depend on the individual, and the industry and sector that you work in, and how hard you're prepared to work. So I'd say, and also there's certain amounts of risk depending on how much you earn. So one thing that's probably important to know is the more you earn, the more visible you are, and the better you need to do your job all the time. So, but you know, an engineer is a very well-paid job, and I would say that you know, a typical graduate engineering salary, so someone that's just come out of university, would expect to be earning mid £20,000. But you know, there are Formula One engineers and space engineers, satellite engineers that are earning well in excess of £100,000 a year.
Wow, that's amazing. And I must ask you, so EEU were your grades at A level? Sorry to bring them back up, Kieron, but
no, two E's in the U, yeah.
Yeah, but look at where you are now. Just talk me through that. The students, like myself, actually, who weren't that academic, but then, you know, I wouldn't have ever thought someone with EEU at A level would go on to be an amazing engineer. Just give us a bit of hope, will you, please? Because you've done it.
The thing is, it was very, very difficult to understand at the time what the problem was. But when in hindsight, looking back at it now, and even when I finished my degree course, it was very clear that I was not interested or not able to learn the pure academic subjects. So when I was at school, we also had O levels and CSE. So there were two qualification routes that you could go down. O levels were for the ones that were sort of highly streamed for academic purposes, and I wasn't in that stream, so I was probably not really supported well enough at the time then. And then I wanted to do A levels, and my advice, the advice that I've been given to do A levels was purely for the purpose of getting in to do a degree in engineering. And it really, I'd had some, you know, the advice structures around us at the time weren't as good as I believe they are now. That there are many other ways and you should choose the way that suits your way of learning. And if I was to do it again, I would probably go down the apprenticeship route. Certainly the HND route that I went through in a Polytechnic was much better suited, but it was just really difficult for me to learn those pure subjects of physics, chemistry, and maths. I mean, I love them now, and I need to use them every day, those pieces of information that I learned around those subjects, but it was really difficult to learn them without knowing why I was learning them and how they're going to be useful. And the HND changed that for me. So doing that process really gave me, if I hadn't done that, I think I'd be in a very different place.
No, it's a great story, and thank you for sharing it. I've got time for one more question from students saying, how did you raise the profile of your company? Of course, you're an entrepreneur. How did you raise the profile of this company that you set up?
Oh, well, social media is very useful these days. But when we started, you know, we didn't have those benefits. It was really about reputation. And so I guess, you know, you've got to trade on the things that you know are good and useful. And so when we started the business, we traded on our reputation as being good engineers in motorsport and having good project success behind us. And we also choose very carefully which projects we get involved in and which ones we think are going to be successful. But it's now, there's now so many different ways of doing it. And with the DMC, with the Digital Manufacturing Centre, we're very focused on the opportunities that exist around YouTube and Instagram and LinkedIn. LinkedIn is a fantastic tool from a professional point of view. So we do a lot of those kind of activities.
Fantastic. And just final point from you, please, if we could. If I'm in year 9 at the moment, looking for maybe work experience in the next few years, what have I got to do to impress you if I'm trying to get work experience at your place?
You've got to demonstrate that you do things outside of school and in school that are applicable to that sector and my industry. You've got to demonstrate that you're hungry and motivated, and you need to have some demonstration, perhaps, of some hobbies that are relevant to what we're doing, and it shouldn't just be about playing Gran Turismo on PlayStation. That's not enough.
Kieron, thank you so much for your time today. There's been some good questions. The students and teachers have stayed with it all the way through. Got a few positive comments coming through there, but thank you very much for today, Kieron.
Thank you. Thank you for the opportunity to speak to you all.